Hello, good evening, everybody. Okay, so this is structure of organic compounds. We're going to be on page 1 until page 5. Okay, page 1 to 5. So first of all, let's talk about this thing that says talks about organic compounds. Okay, so the word here is organic compound. All right. Now, what does the word organic mean? Organic basically means, in simple words, usually organic, when we use the word organic, it means that something that originates from living matter, or something that is living or was living before. Okay, so it is living or living before, right? So these are considered to be organic. And usually the one very important criteria of something being organic is it must contain the element carbon. All right, carbon is a very important element. But at the same time, there are other elements that contain carbon, like for example, carbon dioxide, carbon monoxide, let's say hydrogen cyanide, calcium carbonate, all right, or calcium carbonate, let's say calcium hydrogen carbonate. All right, things like these examples: carbon dioxide, carbon monoxide, hydrogen cyanide, and so on. These, although it contains carbon, these are classified as inorganic. Okay, so they exist naturally in the environment, and they did not come from an organic substance or something that used to be living. Okay, so whenever we say organic, please remember that it must contain carbon, and it should come from something which was living, is living, or was living before. All right, something from the structure of it. I think that will be better, the structure of something. Okay, so there are many organic substances. In fact, we are ourselves an organic compound. All right, we are an organic compound, and it says here the simplest of the organic compounds is called hydrocarbons. Hydrocarbons, like the name suggests, hydro basically means hydrogen, and carbon. So these elements only contain the element carbon and hydrogen. That's it. It doesn't contain anything else. Okay, carbon and hydrogen. So it says over here. But there are other organic compounds, like it mentions over here, which contains other elements like oxygen. Okay, like for example, alcohols contain oxygen, nitrogen in amino acids, there is phosphorus, and let's say like DNA, and then there is sulfur as well in some amino acids. So the next thing here looking at is something called structural formulas. Now, in structural formulas, it is a formula when it's presented to you, like in this image here. It shows you two few things. Number one, it tells you what atoms are present. Like in this case, there is oxygen, there is hydrogen, and there is carbon. Okay, and it also tells you how they are bonded to each other. Like you can see over here, carbon is bonded by a single covalent bond to this hydrogen, single covalent bond to this hydrogen, a double covalent bond with this oxygen here. And these, if you remember from unit 1, these are called lone pairs. Okay, lone electron pairs. So most of the time you do not need to show the lone electron pair. There is no need to show this, but if you do, it's not wrong. Okay, you can show this. So these are called structural formulas. So it shows you all of the atoms present and all of the chemical bonds that are involved, whether it's a single bond, double bond, triple bond. So those are called structural formulas. So whenever we want to draw structural formulas, right, whenever we want to draw structural formulas, we just need to know that there is a simple rule over here. Okay, simple rule over here that we can follow here. Carbon needs to make 4 bonds. That's it. All right, these 4 bonds can be 4 single bonds, or it can be 1 double bond, 2 single bonds, or it can be 1 single bond and 3 triple bonds. Any of these combinations is possible, right? But it can make 4 bonds, and it can only make 4 bonds. It cannot make more than that. Okay, so next thing is hydrogen. Hydrogen is the gap filler in the universe, that means it can make one bond, and then if you're just lacking by one element, hydrogen just comes and sits in there. Oxygen can make two bonds. All right, so basically oxygen can make two bonds. It can either make two single bonds, like in the case of water, or it can make a double bond with another oxygen. Nitrogen, on the other hand, makes either a triple bond with another nitrogen, or it can make three single bonds, let's say in the case of ammonia. All right, it can do that. So there are many different combinations as well. So if you know this, then things becomes a little bit easier. Next, it brings you to something called condensed structure or semi-structural formula. Now, the whole idea of condensed structures is you know, when you used to use a typewriter or a calculator, typewriter or a keyboard, you know, in initial days of Google or Microsoft Word, it was easier to represent it like this. So this would be called the molecular formula. So molecular formula, if you remember, it tells you the number of each element present. So structural formula is what we looked at. So when you use a typewriter, or when you use the early versions of Microsoft Word, you couldn't really draw structures like this. All right. So to make life easier, what they did was they drew condensed structures. So condensed structure is basically the structural formula, and then you just condense it. You just put things together. So you can see that that's how it looks like, right? So that's a condensed structure. So to be honest, in my opinion, nobody really cares about condensed structures, but structural formula gives you more information. Then there is something else called skeletal structures. Now in skeletal structures, chemists, high level chemists and all that, sometimes they're just too lazy, not too lazy lah. They are just rushing for time. They are not going to draw for you things like one carbon, another carbon, and then a hydrogen here, another hydrogen. They're not going to do that. They'll just say that's it. Okay, so you are supposed to make sense of what this is. So basically, when you draw a line like this, at every end, at every corner, there is a carbon. There's a carbon here, there's a carbon here. All right, there's a carbon. And then this carbon, it must have 4 bonds, right? So one bond is bonded to this carbon. So the others is hydrogen, hydrogen, hydrogen. And here hydrogen, hydrogen, hydrogen. And this carbon already has 2 other bonds. So one more hydrogen here, one more hydrogen here. So this would be called propane. All right. So that's how, so like in this case, there's a carbon here, 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 there's carbon here. And please remember, carbon must have 4 bonds. So this carbon already has 2 bonds with these 2 carbons. So the other one is a hydrogen, another hydrogen here, one hydrogen here, one hydrogen here. And these are the hydrogen. Okay, so these are called skeletal structures. So chemists basically did this. High level chemists who are super busy all the time, they just draw this to make things easier for them. Okay, so one thing when you draw skeletal structures is whenever you're dealing with carbon and hydrogen which is bonded to the carbon, you don't have to show it. Like for example, I just do this. Okay, let's say something like this, right? So I'm not showing you anything else. But if it involves other elements, let's say oxygen. So let's say at the end here, I put an oxygen and I put a hydrogen. So whenever hydrogen is directly bonded to carbon, we don't show it. But if hydrogen is bonded to another element, like say in this case oxygen, so this basically is it's a carbon, another carbon, and then there's a carbon here, and then oxygen and hydrogen. So this is what I just drew here. Okay, so this is what I just drew here. So that's what it is. So that would be the structural formula for this. Okay, so this will be propan 1 all. So whenever hydrogen is bonded to carbon, we don't have to show it. But if it's bonded to, let's say, oxygen, or directly bonded to sulfur or phosphorus and so on, we have to show. Okay, we have to show that. So that's, you see, it says here, if you read over here, it's written here in the notes as well. Let's just quickly go through this. Okay, it says here, in skeletal structures, the symbols of other elements are always included. For example, oxygen and nitrogen atoms. So if it's only carbon and hydrogen carbon and hydrogen directly bonded to carbon, we don't show. Okay, it is also important to include the hydrogen atoms that are attached to this oxygen or nitrogen atoms. All right, so like for example in this case, but in this case you can see they are showing you all the nitrogens and oxygens, but they didn't show you the carbon. So there's a carbon over here, there's a carbon over here, there's a carbon over here. At the end here there's going to be a carbon, there's a carbon at the end here, there's a carbon at the end here. Right, at the end of everything there's a carbon, and we got to make sure that the carbon is having 4 bonds. So like say in this case here, this carbon already has 1 bond here, so that means there's another hydrogen, another hydrogen, another hydrogen. Let me change color. This carbon has 1 bond here, another bond here, another bond here, so it must have another hydrogen over here. This carbon has a bond here, bond here, bond here, bond here. There's 4, so perfect. This has 1, 2, 3, 4, also perfect. This is only 1 bond, so another hydrogen here, another hydrogen here, another hydrogen here. Same thing with this guy, it has 1 bond here, so 1 hydrogen, 1 hydrogen, 1 hydrogen. So that is the structure for caffeine actually. So there's a carbon here as well, there is a carbon here as well. Okay, so carbon is the one we always don't show. So that would be the caffeine structure. So if you can't see this, that's how it looks like. Okay, so that's the structure for caffeine. Okay, doke. And so the next thing that we'll be looking at later on is this one, starting from page 6. All right, that's all for this.